Did I just mess things up? Whoops. What's going on here? Why is this now all of a sudden? All right, 5. Six. I just want to make sure that I didn't screw this up real quick. This should be 4, 5, 6. All right, cool. When you don't have a slice, you'll see that it automatically gives you like a gray ID. So what I'm going to do here is I'm going to select all of these slices that we've created. By the way, this is like the one feature that makes me still use Photoshop. And I'm just going to, by holding down Option and then Shift, I'm going to move this down. And now I can just go in and do girl. This is mundane, but it's way better than trying to cut all these guys out by hand. Should be done soon enough. All right, so I believe that was everyone, and now we can just take this here, and we'll just drag this down and create these slices here. So this will be zombie. And I think the other thing we'll do is once we get these basic guys running, or actually we'll just get them trying to display. Once we get them displaying, we'll take a look at setting up palettes. Just checking them. I have my laptop in a drawer, so it doesn't make a lot of noise, but I just want to make sure that the drawer wasn't on fire. I opened up to feel the heat. All right, so that's all of our sprites. We're going to save out our slices now. And let's save this out and talk about how we can actually export the slices. So now we're gonna hit save, and when we hit save, oh, by the way, this is Command Option Shift S, which does save for web. And what we're gonna do is we're gonna export each of these slices now individually. So we're going to hit save. We only want the images. We want to go to Other. And we want to configure the settings. Photoshop decided to hide its settings panel behind the other thing, so that's good. So we're going to do slice name. And we just need none. None. So this is like a pattern naming thing, but it like makes this like large convoluted name. But it's for like old school, like if you needed to like have like image rollovers from like pieces. All right, so all we want is just to have the slice name, and we're gonna create a new folder. Well, we don't need to put them in a separate folder. Copy background image when saving. Sure, why not? Let's hit OK. And now we're just gonna do all user slices. And that'll just do the ones that we've defined. All the other ones will be sort of ignored. And we're going to create a new folder here, and we're going to call this Sprite Builder. So now, before I create this folder, if we come here and we take a look in Pixel Vision 8, you'll notice that Sprite Builder is basically grayed out. It looks for a folder called Sprite Builder, and if it finds that, then it'll automatically activate this feature of Pixel Vision 8. So let's go ahead. We're going to hit save, and it should generate out all the sprites into that folder. And now when we look at the sprite builder folder, if I could like make this window bigger, you'll see here are all the slices that we've created. The Mac doesn't know how to scale up pixel art. So what's cool about this is that now we can use Pixel Vision 8 to automatically go through and read these images, look at the sprites in memory, and create out a Lua file that'll have all the animations or all the sprites put together based on the file name. And in order to do that, all we need to do is just refresh. You'll now see Builder is available. We click Build, and whoa, we got a null reference exception, which is not good. Huh. Well, that is a pretty serious bug, my friends. Which means I might not be able to do the sprite builder. Wow. How did I break sprite builder? Generate a SB sprites. I'm going to just do something just real quick to see if... I'm just going to put the file in here. Maybe it can't create it from scratch. I might have to... Nope. All right. Hey, look at that. That was a short stream. GitHub/PixelVision8. Well, so here's a good reason why I actually do this testing is because I'm about to release a new version of Pixel Vision 8, and I'm using it myself, and I'm finding a bug. So I'm gonna show you guys how to file bugs for Pixel Vision 8. So I'm using the Game Creator, so I'm gonna file this into the Game Creator project, and basically Sprite Builder is throwing a, what error is this? A null reference exception. All right, so I'll have to fix that later, and then once I fix that, tomorrow's stream I'll sort of walk through how to use the sprite builder. All right, that's upsetting, but you know what? It's better that I get this bug than somebody else does. So let's see what we can do here to mitigate this. We'll just build this by hand, which sort of stinks, but that's the more authentic approach. This is what people used to do back in the day. The real question is, how the hell do I build this by hand? Let's see if we can do something real quick here, just as a I'm inside of, I'm editing the data for the sprite chip, and what I'm gonna do is I'm gonna turn off unique, and let's just see if we can get this to. Oh right, okay, sorry, the sprite cache is still there. Let me delete the sprite cache. Removing unique means that it's going to try to put them together, but that's a mess too. The only way I think we could fix this would be as if we made it 128. I'm just going to do some quick slicing here just to see if we can get this back on track. So removing unique sprites allows you to basically, if the sprite data matches up exactly to the pages in memory, it won't remove the unique sprites, and then we can use this other API that I added, which is for people who come over from Pico 8. So I'm just trying to match this up to what the sprite chip's memory layout looks like. And we'll just sort of hack this together. And then tomorrow we can talk about sort of optimizing. That's annoying. I should have tested Sprite Builder. I can't believe I did a build without testing it yesterday. I tested like everything else but Sprite Builder. But that's fine. I'm not seeing any other terrible bugs so far. Like, I was doing all kinds of crazy stuff working on Pixel Vision 8 Sprite Importer. So the fact that this even works is all right, so let's see if this works. And it works out fine, but I'm still testing out another feature of Pixel Vision 8 anyways. All right, so we're saving this as exactly how the page memory works. In fact, let's just crop this image crop and save this down. All right, so save this and let's reload it. And there we go. Okay, cool. So now everything is in memory. So you can see while this works, it's just eating up a lot more memory and RAM, right? So what was compressed now into one page of memory. So we basically had all of the characters on one page of sprite RAM. But this is fine because what we're going to do is we're going to use a new API called Sprite Block, and we're just going to draw out we're going to treat this as a single block of sprites. And remember, the way that we did it is by just simply telling unique to be false, and everything sort of works as is. And again, you can go in and this is a hidden feature. If you were to go into here and go into the data, there's no place here that shows you how to get this unique on. There's some stuff that I just probably, just because of like not having enough space in the GUI, I won't be able to fix or show. So, all right, so let's close that out and let's go here. So now that we're using the sprite blocks, so now what we're going to do is, all we have to do here is let's do draw sprite block, and we'll do ID 0, and we're going to set it to, let's just set it to 8 by 8. Eight by 8. We're going to make the width. Now the width is in tiles, so it's 3 by 4. False, false, and we're going to set this to draw mode sprite, and we're going to set the color offset to 0, and we don't need to worry about, so on screen false, false. And there's a very specific reason why I set those last two values to false, but we're not going to talk about them right now. Let's just see if we can get this guy to display. There we go. Hey, look. We did it. We displayed a Nintendo sprite. And that's actually kind of interesting. It's actually working. Like, the color limitations and everything. So, like, if we came in here and we changed the background color to 0 and hit Control 4 to refresh. Well, that's bright, but there's our guy. Look at our guy. So let's do this. I want to find what's a good gray. I know these two grays are like so similar. All right, so what is this? Color ID 27. There we go. Wow, it's cool. It It works, and it looks like a Nintendo guy. The only problem is that this is what we got to fix is that these guys are so small, but the sprite limitations are so tiny. We're gonna have to do like a lot of work on the display to make these guys look like they're never gonna look bigger than this. It's a shame. I don't have enough sprite count to make a large sprite for the Nintendo, but that's fine. But now here's some cool stuff that we can do, right? Let's say that local. Let's say, what do we want to do? What do we want to call this variable? Frames. So the idle animation is 1, 2, 3, 4. Jump is 1, 2, 3. And then run is 1, 2, 3, 4, 5, 6. So let's say local current frame equals 1, and what we'll do is local frame delay equals 0.2. Local frame time equals 0. And now what we're going to do is let's just get this guy to animate, right? So all I'm doing is I'm going to set up a very basic counter. And the way that this counter is going to work is we're going to keep track of the current frame. We're going to see every 0.2 seconds, we're going to change frames, and then we're going to keep track of the frame counter. And also the other thing we want to do is local current state equals 1. And now we should be able to do something like this. Actually, let's do current state equals 0 and local sprites per frame equals 12. So if we actually, you know what, current frame should be, yeah, all right, what I'm trying to do is I'm trying to do all the math in my head. If you're just joining us, what we're doing is we're working on getting this very simple sort of Nintendo style sprite to animate. And what we want to do is the current state is going to be one of these, right? So let's set this to 1. And then we'll do local start sprite is going to equal 0. And whenever we change a state, we're going to multiply this all together to find the right thing. This is going to be sort of hokey, but let's just start with something basic right now. What we're going to do is we're going to take this frame delay, this frame time, and increment it every frame. So on update, we're going to get time delay. And actually, before I jump into this, let me just write this down because we weren't able to create an RPack, create sprites for the sprite builder. We did create sprites for the sprite builder. We need to generate we can't do this right now, but we're going to animating with sprite block. All right, so this is what we're working on right now because we're about to hit the end of a Pomodoro. So I just want to make sure that everything is organized. So what we're going to do is let's create a very simple animation loop. And we're going to do that by incrementing the frame time over each frame. And if it goes past the frame delay, we're going to go and increase the current frame and make sure that the current frame never goes greater than the current state. It sounds like a lot, but when you do this like over and over again, it's pretty straightforward. So let's delete this here. And the first thing we have is our current our frame time. So let's do frame time equals frame time plus time delta. Now on every update, we basically get the difference between the last frame in milliseconds. Hopefully it's in milliseconds. And that becomes the time delta, which I spelled wrong. Time delta. Now, if frame time is greater than frame delay, then what we need to do is let's set the frame time to equal 0, and we're going to reset the frame. So I'll just keep some notes here. Increase frame time by last frames delta. And then here we're going to do a test to see if the frame time is greater than the frame delay. All right, so we got that going, and now all we need to do is increase the current frame. So how do we do that? So start sprite. So what we're gonna do is, I gotta just do some math here real quick. Current frame. I think I have too many variables, but what we got to figure out is what do we display? So this is 0, right? So you can start by setting the start sprite to 0. And what we want to do is on every increment, right? We want to increase the start sprite. But before that, we need to calculate next frame. So the current frame is going to equal current frame plus 1. Now, if the current frame is greater than frames current state, then current frame equals 1. And so what we're going to do is we're just going to loop through these current frames. But the trick is that a frame actually represents an offset of sprites. And that means that in order to calculate this, what we need to do is we need to take the start sprite. So start sprite was going to equal, let's see if we can figure this out in our head, right? The current, it's going to be the current frame minus 1 multiplied by the sprites per frame, right? SPF. There we go. So at 0, so all we want to do is just show the idle animation. Let's see if this works. Nope, we got an error. On line 60, frame time. I can't spell, by the way. So that sucks. Hey, look at that. It's doing something. Just doesn't look like it's doing the thing that I want it to do. But it's definitely doing something. Let's I have a feeling that my math is off. This should probably be by 3. This should be multiplied by 3. Right? Because it's, if we look here in the sprite tool, It's 0, 1, 2, 3, 0. So right. So each frame is really its upper left-hand corner. What we'll multiply by 12 is knowing that, well, all right, we'll have to do some other math. That's fine. Let's try this again. There we go. Bam. All right, hey, that works. That's a cool little animation. Sorry about the background noise. My mic is super sensitive towards the window that I'm sitting right next to. All right, so we got a guy. I mean, that wasn't very hard. Most of the time was just spent this morning cleaning up the code. So let's we can give him a friend. So if we want to do this for the female character, this is 137. So let's just offset this by plus 137. Uh, 32. Why is that going to the wrong frame of animation? It might 40. Wait. Oh, I see why. The reason why is because when we get down to here, it wraps. Like, this isn't going to be perfect. What we're really going to want to do is we're really going to want to do this for the this is not going to work very well. What I have to figure out is well, you know what we can do? We can figure out the position. One, two, three, four. Yeah, it's not. This isn't ideal. I don't think that there's multiple ways that we can fix this. Either I could put the start position, instead of just doing it by math, I could put the start position of every frame here. So let's do that. Let's save this, and I'm gonna shut down my Pomodoro for a second and just take a quick break. I'm gonna take like a 5-minute break. Just I gotta go get some water and I just want to step away for a second, then I'll come back and think about it. But here, we're gonna continue to test this out. What I'll do is when I come back, I won't take a full 5-minute break. What we'll do is when we come back, we're gonna create a hard-coded array of each of the upper left-hand corners for the sprite stuff, so we just know where the start position is instead of trying to calculate it, because it's on this funky grid and it's just not going to be easy to do. But yeah, this should be pretty straightforward. So okay, I'm gonna make a note. That's not where I'm gonna make my note. All right, so 5-minute break. Back at what is it? 10. We're just gonna make it 10:30 Eastern. And I'm just gonna go downstairs and grab a drink real quick. I shall return. Go stretch. It's important to stretch. Don't sit at a computer all day. And when we come back, we're gonna get some more animation going. All right, I'm back. A little bit earlier than I said I would. Although my PC is telling me that it's 10:30, but my laptop that I'm working on feels like it's. Oh no, you know what it is? When you're outside of the game creator, it freezes, so it doesn't show you time. There we go. Time is perfect again. All right, so where we just left off was getting some animation going. I was trying to do some clever math stuff, but math is not my forte. So what we're gonna do is let's capture the upper left-hand corner of each sprite frame animation, and then we will we're just gonna use that for the frames. So we're gonna make this an array, and all we need is so 0, 3, 6, and 9. So 0, 3, 6, and 9. And now before we get ahead of ourselves and do this for everything, what we're going to do is let's just go through and fix this. So we're going to look for where we're using frames, which is right here. And we're going to take the total value of the frames inside of here, and we're going to use that. Let's see here. Where was I calculating all this stuff? If the current frame is greater than the total number of frames for this state, then set the current frame back to here. And then what we need to do is current state. So I gotta like use my brain for this real quick. So the sprite should now be frames. Right, so we're using frames, current frame to get to the right index, and then we need to find the nested thing. So we're going to look for current frame. I don't know, let's see if that works. Hey! All right, one of the people's animating. So let's hide the woman for right now. Oh, the alarm clock noise. I'm sorry. You know what? You guys hear my Pomodoro timer. Let me fix that. Preferences. Thanks for telling me. Play alarm sound. Sorry. Sorry about that Pomodoro sound. And I use a Pomodoro time so I can keep track of like working in like 25-minute blocks of time. So, but I forget that you guys hear sounds and I have that stuff muted because it's annoying and you guys don't want to be annoyed either. All right, there we go. So our player is animating for the idle state. And what we're going to do is we'll probably create different individual ones. So we'll do like a guy, we'll do the guy frames, the girl frames, and the zombie frames. So let's see, how can we fix this? Sprite frame. All right, I'm gonna pull this out here. We're gonna get rid of sprite frames. We're gonna do frames, frame, current state. Now, you know, we'll clean this up a little bit later. Let's get this stuff working a little better. What I want to test out now is let's see if we can get the jump animation working. And what we're gonna do is the jump is going to be 1264. Okay, my brain isn't going to be able to remember that. So 1264, and then 67. So now if we change the current state to 2 and play the game. So we now have the basic jump. And now, normally we wouldn't animate the jump like this. The jump is going to be based on the physics. So if the player's velocity is moving up, we would show the first frame. When it's sort of evening out, we would show the second frame. And then when he's falling, we would show the last frame. But at least we get a sense of what that looks like. So let's go back. And now the last thing we want to do is calculate out the run. And oh yeah, the Pomodoro timer is really good. Um, I've been using Pomodoro for the past like 4 years now, and it really helps. Mostly because I would just sit here until like I couldn't feel my legs, and it's not because I like that. It's just because I really get into what I'm working on. So, also the other thing about the Pomodoro time is that it helps me focus on just a specific task. So using this Pomodoro timer is cool because I can go through like today. What we're doing is we're just going through and we're testing out animated using Sprite Block. I want to do. Whoops. Oh, I don't know what I hit. Oh well. Anyways, so this is a pretty good program. So what I wanted to do is let's figure out the running thing. So we need 70, 73, 76, 73, 76. If you're just tuning in, we're animating some Nintendo sprites. Evie did did a really good job on these sprites. What I'm trying to do is just get 128. Just trying to build a very simple test harness for right now until we can start building a game out of all this stuff. 134. All right, there we go. So now we have the run animation. Let's hit 3 here. There we go. Got a little dude running. Hey, SunPX is in the stream. Look at that. We got our artist here. All right, so this is working. This is working pretty good. Some of the things we could do is we can always make the frame delay a little bit lower, which would make it faster. So, so we could play around with that. I mean, honestly, like if we were to do, what is it, 60 frames per second? I mean, I can do the math later. I'll go through and I'll tweak, and what I'll do is I'll come up with a consistent way of cleaning it up. I think right now the big concern, even what we were sort of talking about earlier, was like, or at least what I was talking about, was that the guys are super tiny. The Nintendo limitations of sprites is pretty constrained, so we're gonna have to be pretty creative with the background. But hey, now we got this guy going. Here's what we can do, right? So what I want to do is take a lot of this stuff out of here, and I want to actually create a. I want to go and create a sort of object that will represent our player. Alaz is saying that we should try 08, which probably is closer. It'll just be a little bit faster, right? So you're gonna make it a little smoother. I mean, it all depends on. We could do some pretty granular frame calculations, but we'll leave it at that. Good job. Thanks, buddy. So let's create a new game object, and we're gonna just well, you know what? I'm gonna look at another project of mine, and let's look at what we can basically do is we're gonna create well, there's lots of ways that we can do this. I was just looking at an old code to see how I want to do this. How do we want to do this? Let's create a new Lua file. Did I spell entities right? E-N-T-I-T-I-E-S. Again, can't spell. All right, so what we're going to do is we're going to create some functions that we can use to as a factory in order to build out the parts of the player. Now, one thing that Lua sort of stinks at is that there's no classes. So there are some like hacky ways to make classes, but what I found that I like the most is to create a very basic like data object. And here's sort of how we do that. So we're going to create a function. So function create entity data. And what we're going to do for creating the entity data is we're just going to simply give it a x and y position, right? And then here we're going to do local data equals, and in here we're going to do x equals x and y equals y. So that's going to give us the foundation of our data object, right? And then what we're going to do next, and in fact, let's whoops, I don't want to split that up. Split this to the right, close this out. We don't really need this. And we're going to make this a full screen. We'll go back to Pixel Vision 8 when we sort of need it. But what we'll do is we want to do a new thing here, and we're going to do a function create guy entity. And for the guy entity, what we want to do is we're going to give him an x and y position for right now, and we'll just sort of keep this simple, right? So here we're going to start with local data equals create entity data, and we're going to pass in the x and y value. We want to return the end data. Oops, I was thinking of C# for a second. And here we're going to return data. Now, the other things we want to do on here is we want to create a entity. My brain's like not working today. I just want to make sure that entity is spelled correctly. Okay, entity is spelled correctly. We're gonna see if well, we're gonna create two types of entities, and in fact, we're gonna create this. We're gonna clean up this guy entity too. The next thing we're gonna do is we're gonna create another. So in essence, all we're doing is we're creating a base object that's just gonna store values, right? And we're gonna use our games code to update values on these objects instead of having to create like classes and hierarchy and all kinds of inheritance, which doesn't really exist in Lua. This is I wouldn't say it's a functional type of programming, but it's more along the lines of like a decorator pattern. So we're going to do a function here, create animated entity data, x, y, and delay. And you'll start seeing how I piece this together. But in essence, what we're going to do is, so now, whoops, typos, where, oh yeah, entity, E-N-T-I-T, cannot spell. I don't know why I can't spell. I'm like the worst at spelling. Create entity data. All right, so let's see. We're going to create a create entity data. We're going to pass in x and y. Then on this data, we're going to add the delay, and we're going to make this equal to delay. We're going to add a few other things. We're just going to simply hit return, return data. And what you'll see is that we start building up these like little building blocks. So now for our guy entity, since he's animated, we're going to create an animated entity. And what we're going to do is we're just going to pull over this stuff here. So whoops, that didn't work. Data. So we're going to have a delay, so we can get rid of this frame delay. We don't need to worry about that. We're going to have a frame time, a current frame, and we're going to have data. Why am I doing this wrong? I see what you're saying. I know, I can't spell. I don't know why I'm like so bad today. It's like the beginning, it's like towards the end of the morning, so my brain is already starting to shut off. Thanks everyone for fixing my spelling. This is why we pair program. All right, so now that I've fixed my spelling, let's just go ahead and sort of test this out, right? Now, there's a lot of other stuff that we're going to need to do here, one of which is we can now, on our data class, add our frames in. And let's see, what else can we do? What else do we want to bring over? We can do the current state. So data.current state. And we don't need the start sprite. We don't need this stuff. And we're going to get rid of all this stuff anyways. So now let's go ahead and we're going to create a local temp guy. Well, we'll just call this a guy. Entity. Entity. And we're going to do this by calling create guy entity. And we want to set his X and Y value to 8 by 8. Now, if we were to run this right now, we're just going to get an error because basically Pixel Vision 8 has no idea what this method is. So we need to come up here and call load script, and we're going to pass it the name of the entities. Entities. And we'll save this here. Now if we rerun this, our player is still running, and that's only because he's using the that's the old code. In fact, when we go and we comment out all this stuff, you'll see that basically this all breaks now, right? So if we refresh this, all the variables are gone, and our goal is to sort of fix this in a way that allows us to reuse the code. Now, let's get this guy entity here. What we want to do is we want to figure out the guy entity start sprite. So we're going to do data.start sprite, or we'll just do sprite ID. And we're going to set this equal to 0. And we're going to do guy entity sprite ID as the first value. We're also going to do his X, his Y, and while we're at it, let's do a width and a height, right? So I'm just going to keep adding stuff in here as we go through and figure out what else we need. So create an animated entity. We're going to need the width and the height. We'll pass that back down to the child. I mean, in essence, what we're really doing is we are simply creating inheritance in a very manual way. But when we get down to something like the guy entity, so these are our core base ways of creating data. When we get into like higher level stuff like the guy entity and the girl entity, what'll happen is that we'll abstract a lot of that out. So here, all we need to do is say, here, we're going to create a guy at X and Y. It's going to go internally and set up everything it needs. It's going to get an animated entity data object. It's going to go ahead and start creating stuff. In fact, we're going to change so the width and the height is 3 by 4, right? And it's doing this for us automatically. Delay, what we're going to do is delay equals delay or 0.8, so we don't have to really think about setting up the animation. So this will just be a default value for us. In fact, what we could do is Let's just put that here. And now more and more of our data is starting to be stored in this particular class. So what's next? We're going to take the width and the height value. So there's a question, am I going to calculate the start and end frames with the offset later? Hard coding, it seems. Yeah, so I'm hard coding it now because what's going to wind up happening, and what we set up was there's a folder here and there's a feature in Pixel Vision 8 called Sprite Builder, which would take, whoops, I'm in the wrong project. Workspace, Sandbox, Sprite Builder. Okay, so it's going to take these larger sprite graphics, and the Sprite Builder is going to run through each of these and create a Lua object that'll give us each of the frames or each of the sprites that make up this particular sprite. Since we are confined to using 8x8 sprites, right now I'm just using another feature where I turned off the unique sprite importer, where it just imports the sprites exactly as is, and I'm using draw sprite block to actually just draw the sprite as a grid. So tomorrow I'll fix that bug and we should be good to go. So so for right now we're just going to do this, and we can always clean this stuff up later. So now what we're doing is we should have the sprite ID, the X, the Y value, the width and the height automatically set for us, and everything else should be good to go. Fun fact, if we wanted to, like, let's run this, which is probably, let's see, 65. What's breaking here? Oh yeah, all the frame stuff is broken. So what we're gonna do is let's I'm gonna comment this out for right now, and I'm gonna create a new function, and we're gonna call this function update animated entity data, and we're going to pass in the time delta and the data target in the data. Let me get this up here a little bit so we can see what's going on. And for right now, we're just going to paste this here, but what we're going to do is target. We're going to change the value on all these things. I'm going to go through. I'll clean this up in a minute. I just want to get this one thought out of my head, and then I'll sort of show you how we're going to wire this stuff back up. Yep, typo for delta. Man, I can't spell today. Today's a bad day for spelling. I got to fix. There's supposed to be spell check in this stupid thing. I must not have. How do we get spell check back in Atom? Do I need a plugin really? I thought I had that. Packages install. Disabled or disabled. No, it should be active. Excluded scopes, local, default, source, plain text. Oh no, I think it's source.lua. There we go. Hey, spell check's back. All right. Basically, I just went in there and I had to add source.lua as a file so that it knew how to spell check in there. I configured it on my normal developer account. What was I doing here? I was taking all this stuff and just setting it to a target, and I'll sort of explain why later. Let's see. So, all right, we'll come back to that in a second. all I wanted to do is get this game actually running. There we go. All right, so nothing's animating, right? Because we don't have any animation code. So, so what we're going to do now is so theoretically, because we're just simply rendering out the data that's already stored on this guy entity, we don't ever need to touch this draw again. What I was going to show you is like some other really cool things that if we just flipped the second true, the second Boolean to true, if you wanted to make him run or walk, that's vertical. Let's do horizontal. It's the first one. Bam, we can get him to look left and we can get him to look right. So there's some pretty cool stuff that's built into Pixel Vision 8 to make things pretty easy. One day what I want to do is actually change the sprite importer to understand that, to look for sprites that have been flipped vertically and horizontally, so that you can so you can also go through and I'm watching the also use the wrong number for the delay in your entities. Yeah, I'm gonna fix that. I have to go through and I'm gonna clean up the animation stuff right now. Oh, 0.8 instead of 0.8. I see what you're saying. Yeah, pair programming for the win. Okay, so let's see if we can get this animation stuff working with less typos. All right, let's get rid of this, and what we're gonna do is we're gonna call update animated entity data, and we're gonna pass in the guy entity, right? And what we just got to go through is make sure that as we go through this, this all makes sense. Because what I've done is I've now gotten rid of the delay. We can actually, to make this thing a little bit easier, let's do frame delay. We'll go back and we'll change this name later. Frame delay. What I just want to make sure is that time delta is not from the target, because I was just being sloppy when I was pasting this time. Why is it not highlighting here? You know, there's a whole bunch of other plugins I need to get. And highlight selected. Highlight the current selected word when double clicking. Yeah, let's install this. Minimap highlighted selected. A minimap binding for the highlight selected package. Let's install this and minimap. Let's get minimap too. These are all really good plugins, by the way, for Atom. So let's go back here. And hey, look, now we have the mini-map, which I really love. I love this feature. So, okay. We lost a little bit of space for this, but that's fine. I'd rather take it because now I can actually see, I can actually jump. I was like trying to figure out why it was so complicated for me to like scroll up and down, but all right. So what we're doing is let's just double check that this. So we want to make sure there's frame time, current frame, target. All right, let's just blindly hit refresh and see if this throws an error, which it does. So luckily, the game creator is smart enough to know when you're using like multiple scripts, which script actually has the problem. So we're looking at entities.lua file line 49. So target frame time equals target frame time plus time delta. Well, time delta is right. Target, oh, you know what? Here's what we did. We have not passed in the time delta in our update animation call. So let's see if that. All right, well, it's not animating, but it's not broken. Let's see why this isn't working. So frame time, frame time, frame delay. Let's just print this out and see what's going on here. We'll just run for a second and then go into the debug and see what it outputted. All right, so it is outputting the right. It is outputting the right frame delay. So what I want to just make sure here is that let's see. Print new frame. Oh, you know what it is? I see what the problem is. I'm changing the start sprite, and I think what we renamed this was sprite ID. So let's go ahead and change this to sprite ID. And now if we rerun this, oops, let's go and play it. There we go. Yay! Our guy is running, and now through the magic of manual encapsulation and the decorator pattern, we actually have, we now actually can make multiple of these guys. So like, we could do something like this, guy entity 2, and yeah, no semicolons, it drives me nuts. I'm actually not a big fan of Lua, but I use it because it's like it's a decent enough scripting engine. Plus, this seems to be like the hot flavor for fantasy game consoles. I would actually, one of the cool things about Pixel Vision 8 is that it's actually written just in C#. So you can, you could just write all this in C# and not have to use Lua at all, which is what I'll probably start doing eventually. But I got to keep testing out Pixel Vision 8. Let me just close out this Pomodoro. So we've tested out the animated sprite block. What we're working on now is create entity system. All right, so we'll close this out. Create entity system. All right. Hopefully you guys didn't hear the timer this time, right? So Michael's asking why not use JavaScript, and early on I was going to write this as a HTML5 sort of game engine, but what stopped me was the fact that I wasn't sure I could get the sound stuff to work correctly, so I went to C#. Plus I wanted something that was more native, so it would run a little bit. So it would be easier to compile for desktop and whatnot. So okay. So now we have two of these guys, right? And what's cool about this is that we can actually we can do all kinds of fun stuff. Like let's change this guy's current state. So by default, his current state should be 1. But in init, what we can actually do is change this guy's current state to equal, let's do 3. So we'll have one guy who's running and one guy who's just breathing really heavy, right? And what we could also do is guy entity 1 dot, what was it? It should be, what is it? Frame delay. And we'll make this 0.15 to slow it down. 0.08 I was listening. 0.16, right? That'll be, whoops. Oh, it's control. What did I just do here? Oop, dog's gonna go nuts. Attempt to index a nil value. Frame delay. Oh, I know why. This is entity 1. It should just be. Sorry, the dog's gonna go nuts. All right, there we go. So, long story short is that even without classes in Lua, we are able to do some very basic sort of like entity systems, and that just gives you sort of an idea of how we can configure each of them. Now, I think the last thing, what is it, 11 o'clock? I could stream for like another hour. I think the last thing I wanted to do was to play around and build some palettes. But let's actually get the rest of the characters. Let's see if we can use this entity system really quickly to create the rest of the characters. So where is our guy entity? All right, so here's our guy entity. We're going to create a girl entity. And it's going to do all the same stuff, right? The only difference is that we're going to change the frame stuff. So let's move the game creator over to here. And let's look at our sprite table, and we're going to look this up. So this is going to be 137, 137, 140, and 192. 140, 192, and 195. Next, we want the jump, which is 198, 201, 198, 201, and 204. And then the last one is going to be 256, 256. And then it should be every 3, right? 259. If I can't spell today, I'm not going to attempt math. 262. Here's a good time where you get to see my dyslexia too, where I probably will mix up the order of the numbers. 265. Whoops, wait, what was it? 265, 268, and then this should be 320. All right, so that will create the girl, and let's change. So now we can immediately change entity 2 to this new method. Right, so create girl entity. It's a little confusing because it says creating a guy entity, but it's really a girl. So we're not going to dig too deep into that today. Let's refresh the game, and there we go. So now we have a pretty straightforward system for creating different kinds of entities. The last we're going to do is let's just do the zombie real quick. And the zombie is going to be pretty straightforward. It's only going to have one set of frames, which is just going to be run. And the zombie, whoops, where am I? Let's close it out. Luckily I haven't found, oh, I'm going to say this now and then it's going to, luckily I haven't found too many other bugs, so I'll find like a corner of my desk to knock on. Let's see here. So let's do 323, 323, 326, 329, right? 326, 329, 332. So 384. And the last one's going to be 387. 38. All right, so now let's create a zombie entity. Let's replace this with girl entity. And the last thing we'll do is we're going to create a zombie entity. Create zombie entity, and we're going to put this at, what is it, 48, 90, we'll just do it at 96. So we'll just leave this stuff as the same, and now all we need to do is duplicate this and call this zombie entity. So chase, they chase. Yeah, the zombies will. They're actually going to appear from the right hand side of the screen and then go left while the people are running towards the right. So your job is really to sort of jump over them. Let's replace all that. We'll save this. Yeah, there's probably a way to recycle more code, but in all honesty, like you wind up starting to you're starting to boil the ocean, right? Like what I don't want to do is like spend time creating this table just to override it. Like I could probably move a lot more of this stuff. In fact, honestly, I could probably let's put this in here, sprite data. Current state could be sort of the same. You know, there are things that we could definitely reuse. I'm not terribly worried about it though. You know, this kind of manual configuration is par for the course in Lua. Like you're just not going to get around it. The real thing is like what I designed this for is you could sketch out your ideas. So like really quickly, we're just creating a very simple test bed for these sprites, right? Oops, I probably have to switch out. Did I not call create zombie? Why is that? Why is this frame animation not working right? Zombie NT, zombie NT. All right, I was like, I distracted myself, but long story short, like we'll fix this in a second. I know why. I'm not updating it. So what we're doing is the whole idea of Lua and why I added Lua in this game creator for Pixel Vision 8 is I wanted you to have like a really cool place to sketch out game ideas and test things out. And Lua is really fast at that. When you're done, like so, ideally this tool is used for a game jam. And when you're done sketching out your idea, go ahead and you wind up just porting it over to C#, and you can create a more like native like game out of it. And that was sort of like the frustration I was feeling with the other fantasy consoles, is that once you build something really cool, you're really confined to Lua. So I wanted you to be able to move off of that pretty easily. So let's go ahead, and what we need to do is update this zombie entity. And now if we rerun this, we now have our three main entities for the game. Try using 12 instead of 16. Sure, I could do that. I mean, right now I'm just sort of doing some basic testing. Okay, so I mean, look, honestly, like in less than an hour from scratch with a lot of typos and even a 5-minute break, I wound up building out this little basic demo, and of course it took me an hour just to clean up the artwork and stuff. And there's not much you can't get around the production stuff for like cleaning up the artwork and everything. But you know, I think this stuff looks really good, right? The next thing that Evie and I have to go through and do is we have to come up with the background stuff. And one of the things, yeah, I agree. I think this does look better. One of the things that we're going to do is we got to come up with so for the background stuff, we need to. I want to actually take advantage of some of the cool background layering that you can do in Pixel Vision 8, sort of like how the Nintendo did have some ways of doing parallax scrolling. You just had to like hack the hardware a little bit, and there's some things in there that allow you to do that. Baruch, I believe I'm saying your name correctly, is asking, do you think that Lua is good for game developer, for game dev beginners? I do think it is a little bit better, especially when it's in a self-contained environment like this. I think it's a little bit better because it's more forgiving than trying to create classes and trying to keep all that stuff organized. I could have just put all of this entity stuff inside of this code file and kept it really simple, but I like being able to separate out business logic from the game logic. So you know, you have a little bit more leeway with Lua than you would with other languages. All right, so there's one last thing that I want to do, and what we're going to do is let's take a look at building some palettes. So there's palettes aren't natively built into Pixel Vision 8. There are some things that we can do to sort of simulate them. One of which is we have this thing called color offset. And if I was to change the color offset by 1, you'll see that the colors sort of shift over. But right now, because of the way that Pixel Vision 8 is parsing the color data, it's actually matching the color IDs up to their position in the color PNG file. So if you have a color here, here, and here, and you shift it up by 1, it's going to go to the next set of colors, and it's not going to look right. What we're going to do is we're going to redo the colors of the sprites and get them to be indexed a little bit cleaner. And we're going to build out some palettes to hopefully make shifting the colors for all the sprites a little bit easier. Now, I got to really think through this and how I want to do this, because traditionally on the NES, what would happen is you would build out. The NES had a limitation of. I think it was. I'm gonna stand. So sorry if you hear the mic moving. I just gotta like stretch for a second. So let's sort of talk through how we're gonna do this now. Technically, what would happen is that each sprite would be mapped to a palette. And a palette would just contain a set of colors from the system's available colors, right? Now, one of the things that I really spent a lot of time trying to figure out, and it's not the normal sort of palette solution you'd find in game engines, I have sort of a custom approach to it, is how do we make palettes a little bit easier and a little bit more flexible? So what we're going to do is we're going to treat an entire sprite here as a full palette. And in order to do that, we're going to need to pull out all the colors that make up this sprite. And we're going to figure out, what we're going to do is we're going to match the number of colors to what we call a color map. And we're going to remap the colors when it's imported. And this is sort of complicated. So I'm going to walk through how this works. So let's just take this one sprite here. And I'm going to, whoops, I don't know what it just decided to do. Let's copy this sprite. Come on, Photoshop. Oh, you know what it is? When it's one layer, I can't use that other shortcut. All right, we're going to paste this guy here. Let's get rid of this background. Oops. And let's just set this to GIF, no dithered. And this right here are, these are the 1, 2, 3, 4, 5, 6, 7. So there's 7 colors, one being transparent, right? And I think what we're going to do is we're going to create a palette of 8 colors. And we're going to map the entire sprite over to that. Now, you can get super granular in Pixel Vision 8. If you wanted to treat this exactly like NES hardware, you can tell each sprite exactly which palette to do. But because we want to keep this simple, we're going to treat this entire thing, even though it's made up of multiple sprites, as one sort of entity. So let's just take a picture of this. And I'm going to open up. Here's our colors PNG. Let's go back into Pixel Vision 8. I should actually make a note for myself to do this, but what we're going to do is, I want to do this. I'm going to go into the project itself, and we're going to go to data, and we're going to look at the color chip, and we're basically going to make 2 pages of colors. And now if we go back to the color chip, the first page is going to be the system colors, right? This is the default colors that the Nintendo was able to use. On the second page, we're actually going to store the palettes themselves. And what we need to do is we just need to get Pixel Vision 8 to the point where it could just save out a color. So I'm just going to make one color here, and we're going to hit save. And it's going to rebuild our color palette. And now there's one thing that I'm noticing here that I don't like, and this is something that I need to fix, is that it's rebuilding this should actually look like the page memory. I need to sorry about the noise as I readjust. Thanks, Evie. I'm glad you like the UI. It's that was Saint 11 created it, and wait until you see the new stuff that we're doing with Castpixel. She has some amazing UI stuff that we've designed. So there's one thing I'm getting annoyed about here, and I want to file a bug. It's that GitHub. Let's go into the game creator, and let's go to issues, and let's create a new issue. What I just want to make sure is that color export should be what is it now? It should be whoops, I think it's 8 across, right? Yeah, it should be 8 colors wide. Need to fix color PNG file so it better matches up with colored chip memory space. I think what I was doing was let me just file these bugs real quick. The new system will be 16 colors, but we're not going to display 16. We're not display. We're not going to. I'm not doing 16 colors right now. So for this version, it should actually just output 8. Because what really should happen is that this should look exactly like what you're dealing with here. But for right now, we can. We're going to just sort of fake it. So let's take a look at how color mapping sort of works. So now I did take a screenshot here, and we're going to put this guy over here, and what we're going to do is let's just lift these colors. So now this represents our second page of color memory, and take a look at how we're going to do this. Actually, we can just do this like this. So I'm going to take each one of these colors, and the last one's transparent. So this is this should be 8 right here. And now if we look at the, so all right, so we're going to keep things simple for right now. This represents our first palette. And now if we come back in here and we refresh this, we'll see that now in the color space, starting at 64, we have our first palette. Now, let's pull up our sprites here, and let's say we want to change. We can copy this palette down here, or actually, what we'll do is we'll move it right here. So we're going to say that every eight colors ish is basically a palette. We could do it a little bit. Would there be enough on a row? No. All right, we're going to keep it at 8 just to keep things simple. So now, if we want to swap out, let's say we want to where didn't I pull out this guy? Yeah, here we go. Let's test this out, right? Like, let's say we want to change his shirt color, right? So all we need to do is take this green, and let's give him a. Oh my God, I hate these like gigantic tooltip things that pop up that show you videos of how to use Photoshop. It's like the worst of video game tutorials. Let's say we want to change his shirt color, right? We can make it, I don't know, red. That's a little too bright, right? Let's do a darker red. So all we need to do is paste that there, and we want to change his blue jeans. Now this is where it gets really interesting with the Nintendo, right? Because now on a real Nintendo, I could isolate this one sprite and change its color, but because of the way that we're sort of simplifying palettes, we're going to change the color globally. So let's just make this like a darker brown. Right? And so all we need to do now is just change that color there. And what we'll do is, why don't we change this to something a little bit lighter? I don't know. Colors are not my thing, but there you go, right? So it looks a little bit better. What was that color? I think that was this brown. Why do I have that must have been the first brown, right? So I lost everything. What was I using? I used this, right? All right, so who knows? Whatever. We'll just keep it simple. All right, so we swapped out these colors, and now let's save this out. So if we come back into Pixel Vision 8 and we refresh, you'll now see we have 2 different palettes, right? And I'm going to show you how we can basically swap between these with the player. Now, before we use the palette, we have to remap the colors. And this is where it gets a little bit confusing. So what I'm going to do is I'm going to create a new PNG here, and we're going to call this a color map PNG. And hit OK. And now I've used this, I actually use this all over the place. Let's see if, do I have anything that uses the color map here? I don't. I have it in documents. Well, let's just go into Pixel Vision 8 itself. I'll show you where I use it. Show package contents, resources, data, streaming assets, system, game creator. One of these has it. Pixel Vision 8 tools. Let's just use the chip editor for an example. When we look at this color map, I'm going to open this guy up in Photoshop, and I'll sort of show you what's going on. I use this really ugly set of colors, and what we're going to do in the new color map PNG, which I don't seem to have here. Did I not just save? Oh, I just didn't. I have to open it back up. Let's open up this color map. We're going to leave the colors on the first page exactly how they are. And the way that the color map works is that it loads up the color map first, and it compares it uses that as the index for the sprites. We're going to change the sprites to be a very specific set of colors that match up exactly to our 8-color palette. And it's going to be sort of hard to explain, but I'll sort of try to visualize it real quick. In our palette map, oops, let me do this. Okay, so here is our color map, and here are our colors. What it's going to do is wherever it sees this color in the color map, it's going to be index 0. Wherever it sees this color is going to be whatever index is. So by using the same system colors at the top, we're remapping the colors just as they were before. Everything will work fine. Everything is great. Now, when it comes to something like this, where we have this different red color that isn't part of this palette, it's going to map it exactly to here. So wherever it sees that red is going to be mapped to here. And what we're going to do is we're going to change our sprites to actually use these colors instead. And that's going to put all of our sprites into the first palette color space. Now, I need to figure out I don't have an easy way to really do this, but we're going to, eventually I'll come up with a solution for it. So the way that I do this mapping is going to be something like this. Let's take this out, and I'm going to put these colors here, and then we're going to take the color map here, and I'm going to paste this down here. Oops, that's the wrong one. And let's just combine all of this now into a single sprite sheet. So now what we're going to do is we're going to go color by color, and we're going to replace Actually, what I want to do is, and I don't want to do I don't want to do any of the other sprites right now. So we're just going to do, we're going to do this. And we're going to pull this layer out and paste it back down and then just reorganize it. Okay. So now if we come back here, let's hide the grid because we don't need it. We're just going to like manually remap it. There's some other faster ways to do this in Photoshop, but I just don't, I'm just feeling like especially lazy today. Wait, why is this not, hold on. Get rid of continuous. Interesting. So I must have a different color space because now that brown didn't, oh, you know what? That stinks. I have a feeling that, when I took the picture of the PNG export, it didn't give me the exact same colors. So let's just remap this real quick. This is annoying. That's fine. All right. That was my fault. I should have done this a little bit better. That's the only problem with this that's the only problem with this thing where you wind up where if the color space is off by just a little bit, nothing works. And you could import sprites and then all of a sudden be like, "Hey, what the hell? Like nothing's working. I don't get it." And get really frustrated. So I have to I'm probably gonna have to just use a better sprite, some better, tell people to use like better sprite tools that do indexing, and this way people will be able to basically always have the right colors for Pixel Vision 8. CastPixel actually created a new palette for Pixel Vision 8 since we're just using the Nintendo stuff. That's a little different. Okay, here. So the whole thing, you can sort of see it now. This whole palette is selected. We have the colors are matching here. And now what we need to do is we can go through and we can literally just replace the colors. So we're going to go, actually one thing I need to do while we're at it is let's just make sure that these colors are correct so that when we remap it, everything looks right. I bet you can't even see the difference. It's like just very slightly off. And that's just the difference between taking a picture of something and it being just slightly compressed, right? But let's go through here and we're going to replace the red strap. We'll replace this tan with green. We'll replace this blue with yellow. Now this is going to look stupid ugly, right? But the other way to do it is with grayscale. I mean, it all depends on how you want to do it. I like to just be able to clearly see the palette mapping. But generally, if you build it from the ground up, you would wind up with a pretty good looking set of colors. This is just ugly, 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 ugly. But now, if we select all the colors, we'll just make sure that we're in the palette space, and there we go. We now have our clean palette, and it's just for the player. It's very 90s feeling. It kind of works in a weird sort of way, right? Let's flatten this layer, save it, and we're going to save our colors PNG, our color map PNG. And if everything works correctly, if we come back into our sprite tool here and we go to page 1, that's wrong. Oh no, it's right. It is right. Because what's happening is that it is using the color index to remap to this new palette. Again, I gotta figure out a way to simplify this or explain it a little bit better, but it's really hard to sort of see, and the tools don't show you right now. Like I need to get something where you can at least toggle on and off the palette stuff. So anyway, so here is our guy. So now if we went here and we changed this by, well, saying it to 0 is going to not do much, but if we changed it by 8, you see his hair turn brown, right? That's because the next palette set is brown. What do we change that was a little bit more? Oh yeah, 8. Look, so see how his shirt's red now? So now we can actually do some pretty good palette swapping. You'll see the tool retains the offset. So as I go through here, you'll see his shirt has actually been remapped because that's where the color is, and his hair is going to be brown and stuff like that. You can also do some cool stuff like whatever the background color is. If you wanted to preview what it looks like with the background color, you can add in or out the background color. So all right, so now our guy is mapped to a palette, and what we're going to do next is let's go into our code and let's go back here. We're going to make the girl set to a guy, and what we want to do is on our create guy entity, we're going to create an offset. So we'll actually call this color offset. And on the data object, let's just go and create data color offset equals color offset or 0. And now, since we're not supplying the offset, that's going to be fine. Here, we're going to change the offset and we're going to make it 8. Remember, we want to shift each individual index over by 8. Now, you can play with this. Like, there's some cool stuff that you can do. I don't limit. Well, let's just show this and see how it works and make sure that everything works correctly. Then I can sort of talk about how this works under the hood. But here, we're going to make this color offset. And we'll paste this and make this girl. And we'll paste this and make this zombie. Right? And now, whoops, and now save this and let's rerun it. So now the guy here, you'll see the guy on the left is actually, his shirt's green, but the guy on the right has a totally different palette. And there's some cool things that we could do as well with this. Like, this isn't ideal, but let's just say every time we changed, this is going to get weird fast, but just to give you sort of an example. Now, in traditional game engines, or like these older 8-bit engines, what wound up happening was that, let's go ahead and every time we change frames, we're going to do color offset plus color offset equals color offset plus 1. Now, in traditional game engines, these old 8-bit games, what would happen is a palette was sort of fixed. And what I'm actually doing is every color pixel on the screen is really just an index. It's a number. By changing the color offset, you're shifting each one of those indexes over by the value you supply. So if we were to rerun this, you'll see that it breaks. Entities Lua 98. What did I do wrong? Oh, that's because I'm using guy entity and this should just be target. All right, so if we rerun this, it's just going to keep crashing. Why is it? Attempt to perform arithmetic on a nil value. Color offset, target color offset. Oh, that's because the guy... All right, let's move this code into the entity. And we'll do this. And then whenever we do animated delay color... Oops. Color offset. So we'll just bring this back down to all the different layers of code to create stuff. So that's the color offset there, and we'll do color offset. And we just need to add this to the other ones too. Right, so now we can create different color offsets, and let's... All right, so what you're seeing is that it actually goes through and, well, that's cool how that one dissolved. So what's happening is that it wound up running out of pixel space, or out of color space, right? But what you're seeing is that each pixel is being shifted over one by one, and it's going all the way through all the colors. Then eventually it just runs out of stuff. So now what you're seeing is that way that it actually disappears is how you would animate something disappearing in a game. You would just simply change the palettes and just make each color clear over time, and it would go away. So that's just some basic stuff. Now of course we can clean this up a little bit. If you're really clever about this, my brain doesn't really work like this well in this space. But you could actually, instead of shifting them over by full palette sets, you can shift them over a little bit, and you can create, like I've done it in a few places in the tools where palettes sort of match up with each other, where if you keep looping through them, it would go like in sets of 2s, even though the palette was a 4, and they wrap, and you can do some pretty cool stuff with it. I'm gonna get rid of this piece of code, but in the end, that's basically how the palettes work, and I think we've done a pretty good chunk of code for today. That now you can see by just reorganizing the color space and changing the way that the colors are indexed when they're imported, you can actually come up with some pretty cool results. And in fact, if you're thinking of palettes from the beginning, you don't even need to include these palettes. You could actually just start with the palettes you want, and just in your own art program keep a reference of the color space you're using. So I think the last thing we should do is we should go and try to get the girl working, and I'm trying to just think in my head how I want to do that. I don't know, I'm sort of running up on time. I think, we'll save that for tomorrow. Tomorrow what we'll do is, I really want to get the sprite builder working, although this example kind of works good. I think tomorrow what we'll do is we'll add some more palettes. We'll make some variants on the zombie. So what we can do is we could do trying to think this through here. We'll do 2 variants of the people, and then we'll just do 4 palettes for the zombies, so we can have different color zombies. And I also got some new artwork from Evie. I got some furniture we'll add in too, and then we'll get the sprite builder working, and hopefully by Wednesday we'll be able to start building a very basic little game. What I'd like to figure out is some of the physics, because I did this in Unity originally, this example game, and in Unity it runs easy because there's a built-in physics engine. We're gonna have to build all the physics from scratch. So making sure that when a piece of furniture comes in from the left-hand side of the screen, that it actually pushes the player. There's a lot of stuff that we're gonna have to figure out that's not normally in my wheelhouse, but I'm kind of excited. I think this worked out really well, and thanks everyone for watching. And I don't know if there's any other questions or stuff. I'm gonna be here tomorrow at 9 a.m. Eastern, so I'll see you guys tomorrow, and that's my stream. Thanks for watching.